Before we get started, Alex actually gave already a small introduction. So Paul is our head of data science and research. I'm mostly ICE Chief Trust Officer. What does a Chief Trust Officer do? I work a lot with regulators on the European Union level, UK level, with data protection authorities, and I do a lot of our public speaking and presentation at conferences. Who is also with us, who you haven't yet seen in the invite, is our colleague Dilara Humus-Bas, who is a senior data science consultant with Mostly AI. And today we have the pleasure to have her with us for the full 1.5 hours. She will monitor the chat, and in case you should run into any technical issues, should have any questions, can't find a data set and so on, she will be there to help you. So if you have any questions about tech things, just look into the chat. Dilara, I see we also have a FAQ section and a chat section. Can you see both with your permissions?
Yep.
Perfect. Then we can get going. So what do we want to do today? Well, what you will learn today is, on the one hand, what AI-generated synthetic data is, because it's not a clearly defined term yet, and there's AI-generated synthetic data and not AI-generated synthetic data. But in our opinion, AI-generated synthetic data is much more interesting and also useful. Then the hands-on part will be creating your first, or maybe not your first, super realistic and representative synthetic data set. And you will see that this is actually a super easy and straightforward process that will take you just a few minutes. Then I'll hand over to Paul, who will do some machine learning with you, because machine learning is actually the best way how you can assess the quality and the statistical utility of your data set. So you will train a model on the original, the real data, and a model on the synthetic data, and then you will compare the performance to see if the synthetic data is as good as you would like it to be. And lastly, we also have a little bonus exercise for you, because synthetic data can not only help you to unlock your existing data in a privacy-safe manner, but it also can help you to improve your data. And one of those examples is actually smart upsampling, where you can create more examples of minority classes or rare events. So for example, in fraud detection, this can become very handy and very useful. So we will also look into that. Before we go into the section on what AI-generated synthetic data is, I thought I will also go over some housekeeping items or share with you what you can do to get the most out of today's session. So this tutorial is for you. Paul and I really want to make sure that it's valuable, that you can get to take away what you want to get to take away from it. So if you have any questions at any time, feel free to ask them via the chat. Feel free to unmute yourself if you have the possibility. I'm not sure. If you don't, Dilara will be your voice and interrupt Paul and me while we're speaking if there's any relevant question that we could answer right away. So always happy to hear your questions and really tailor this to where you're at with synthetic data and what you're most curious about. Second, what tools or what data will be used? And actually, there are three things that we will need today. The first one, as already mentioned, is the Mostly AI synthetic data platform. Just double checking, I hope you have signed up for that by now. If you haven't found the link, you can also just go to our mostly.ai website, go to sign up, and you will be able to find everything you need there. So that's the first thing we need so that you can create your synthetic data. We will also need our AWS bucket. Dilara can share a link with you in the chat, where you will find the original data that we want to synthesize, but also all different, let's call it milestones, different steps that we want to reach in today's training. Why is that useful? You don't necessarily need to have anything else besides the original data set, but in case your platform is not synthesizing the data as quickly as, for example, we are proceeding, or if you get lost somewhere along the way, you can just go there and grab the data. But actually, Dilara already prepared a Colab notebook for you, where all the data will be grabbed rather automatically, so not too much should be done from your side. We will use Google Colab then later when Paul is doing the machine learning with you. For that, as many of you might already know, and I assume many of you will have it, you will need a Google account, otherwise it doesn't work. So I hope not too complicated, not too many technical and tool hurdles we put in here, but that is what we are planning to using today for our interactive parts. Lastly, as already mentioned, at any time, if you can't find something, if you have any tech issues with Colab, with our platform, with the AWS bucket, whatever, please use the chat, please reach out to Dilara, and I'm sure she will come to your rescue and help you to resolve that issue. So with that said, let's dive into synthetic data. Unfortunately, I can't see you right now because otherwise I would have asked who has heard about AI-generated synthetic data before or even used it or generated it yourself. For those who are sitting here and are like, well, wait, what the heck is synthetic data actually? I'm honored that you signed up for this tutorial anyway without knowing that, but I wanted to give a quick introduction so that we're all just on the same page. Synthetic data is actually a technology that 8 out of the 10 largest US banks already use and invest in. It's also a technology where regulators and public sector institutions, like, for example, the European Commission's Joint Research Center, are really big fans of. For example, in a recent report from a few months ago, the Joint Research Center of the European Commission stated and concluded they assure that synthetic data will become a key enabler for AI in Europe, both in business as well as in policy applications, because it helps to unlock training data that you need for AI in a privacy-safe manner. So before I resolve this question, what is AI-generated synthetic data? Just as a little bit of context, why is synthetic data needed? Why do we even need to think about privacy and unlock our training data to make it available for our machine learning and other analytical projects? Well, I think many of you would know that nowadays we have significantly more data than 5 years back, 10 years back, 20 years back. And this is on the one thing, a good thing, because that's so much value that we can use as data scientists and for analytics to improve our business processes, to improve our services, to cater to our customers' needs and become much more personalized than it was even possible, let's say 20 years ago. But at the same time that data is growing, it's also increasingly more complex and difficult to actually get hold of this. So I'm not sure what's your business reality, your day-to-day reality, but we at Mostly AI, we actually work a lot with some of the largest banks, insurance organizations, telecommunication providers, and so on. And most of those data scientists and people that want to work with data always complain about the cumbersome and bureaucratic processes, how challenging it is to actually get data. For many, it's a week-long process if they're lucky, but more often it's often many months until you get the data set, particularly if you want to externally share it, use it for cloud services, and so on. And then it's oftentimes also not as useful as they want it to be. So not the best situation if you want to have fast access to data. And sorry to break it to you if you're not already aware, it's not going to get easier in the coming years because there's actually a whole bunch of new data and AI regulations that are on the horizon in Europe alone and also in other parts of the world. So for example, Gartner predicts that already by next year, 65% of the world population will have its data governed under modern privacy regulations. So we can expect privacy to change. And of course, that's a good thing because I personally like my privacy to be protected. But on the other hand, I'm also aware how much potential we have in data. And I'm a fan of finding ways to unlocking that for societal as well as economical purposes. Some of you might now ask, well, if privacy is an issue, why not just anonymize the data? There are traditional techniques like masking, obfuscation, and so on. Why not just use that? And the reason why that's not something that we recommend or actually also would proactively warn to do is that there's vast amount of research out there showing that legacy anonymization techniques like masking, like obfuscation, and all the others fail for big data. More precisely, there are two problems when it comes to legacy anonymization. The one thing is the utility, and the other thing is the privacy protection characteristics. As you can see here on the slides, I would assume everybody can guess correctly who the person on the left is. Not that difficult. So everybody would agree, I hope so, that this data is not sufficiently anonymized because you still have privacy sensitive information in there. Same holds true, by the way, for the structured data on the right. But for us as humans, it's much harder to guess if this is sufficiently anonymized or not. With images, we can see. With structured data, it's not that straightforward. So what about doing that? Well, some could argue that this data is now fully anonymous, but maybe there are even ways to find out how to re-identify that. And actually, if you look into the status quo of the research, it's super likely that even this data that doesn't have much utility left can be easily re-identified. The problem here is that whenever you leave at least some parts of the data intact, it becomes possible to link this to some auxiliary information. And this is something that allows for re-identification and that introduces significant privacy risks. At the same time, it destroys all the utility because a data set that looks like that and doesn't have that much information left in it obviously isn't your ideal scenario for a data set that you want to train AI on, you even perform some more basic analytics. So to make this a little bit more tangible, one of these papers, for example, figured out that when we look into credit card transactions, where most banks, I would argue, have at least a few dozen credit card transactions per customer per year, sometimes even many hundreds. And out of these vast resources, out of all this valuable data, researchers identified that 3 credit card transactions alone were sufficient to re-identify over 80% of customers. And it wasn't even the full information about the 3 transactions that was shared, but solely the merchant and solely the date of the transaction. So just tiny pieces like I bought a coffee at Starbucks yesterday, or I shopped, I don't know, a new cake pan at Walmart, could be sufficient to identify 80% of your customers. And I think this illustrates quite nicely that traditional anonymization really has huge issues when it's applied to big data. You don't have the utility you want, and you definitely don't have the privacy protection that you want to have and that you should have with your regulation. And these are some papers that are highlighting this, so we can share this afterwards. If you're curious to dive deeper, you can do that. But what does this all mean for many organizations that want to utilize their data? Well, they have this ever-growing gap for innovation because they have much more data that they can actually use with traditional anonymization techniques, because already a handful of attributes could be too much to safely share. And to solve this problem, that's where AI-generated synthetic data come in. So let's now quickly go over what AI-generated synthetic data is and what it can be used for. Dilara, at this point, do we have any super urgent questions that I should answer?
Nothing yet.
Perfect. Then I will continue, but just a reminder, if you have any questions or curiosities, just put them down in the chat. So I like to explain synthetic data with showing images because it's easiest to understand, but please keep in mind, we at most AI work only with structured data, with tabular data, and this is also what this tutorial today will be about and what you will be working with. So these images are solely for illustration purposes. But as you can see, the pictures we see here look super realistic. Again, if I would be able to see you, I would maybe ask who thinks that these are real people. But I assume you could already guess that the data you see here is not real, or the images that you see here are not real. They are synthetic images that were generated by NVIDIA already a few years back as part of a research project. And what NVIDIA did there was that they trained a synthetic data generator, a deep neural network, on hundreds of thousands of human images, up to the point where this algorithm really understood how does a human face look like. And this algorithm probably learned, well, there are 2 eyes, they're roughly positioned in the middle of the head, noses come in these shapes and sizes, mouth is in these shapes and sizes, these hairstyles are common, the skin colors, and so on and so forth. So it really tried to understand the logics of a human face, not learning everything by heart, but the logics, the concepts. And then once this training process was completed, this synthetic data generator could be used to create completely new synthetic faces from scratch, as you can see here on the screen. So the people here have never existed before. And it's also not a blunt process where you just take the pair of eyes from the first picture in your training sample and mix it together with the mouth of the second picture or something like that. It's really creating new data from scratch. And that's the beauty also when we apply it to structured data. So as mentioned, with our customers, they most often use it for financial transaction data, insurance claims, any other behavioral data, location data is possible, demographic data, healthcare data, you name it. Anything you can put in a table, our tool will be your best friend if you want to anonymize it and make it privacy safe. How does this work? How does our platform work? Well, for most of our big customers, we provide our software and they do everything themselves. But today we will work with our free version that can help you to do the same thing online. And the process goes like this. You have your original data in the CSV file, Parquet file, or in some of your databases. And the software can ingest this data, and the deep learning algorithm can automatically extract the patterns, the correlations, the time dependencies, the structure within that data. So to say it simple, our algorithm can understand how the customers of a bank behave when they go to the cash retrieving machine, what they buy, I don't know, when they have bought a coffee yesterday, what's the next purchase, and so on. All of these information can be learned by our software. In addition to this deep learning algorithm, we also have different privacy mechanisms in there that make sure that you learn as much as possible without entering into the danger zone when it comes to privacy and re-identification. So synthetic data gives you super good results, but it never preserves 100% of the original data set's utility, because that wouldn't be possible due to privacy. But back to the workflow. So you have the original data, the software, the deep learning algorithm trains on the data, learns structures, and so on. Once this training is completed, in a completely separate step, at any later point in time, you can generate new synthetic data. And you're not bound to the size of your original data set. So let's say you have, I don't know, 1 million customers, and you want to generate 10 million synthetic customers, or just 100,000, your choice. You can set that, you can generate your synthetic customers and their synthetic financial transactions. And what you will get is a data set that, from a statistical point of view, is nearly indistinguishable from the original data. It will have the same correlations, the same time dependencies, the same structures, just as your original data. But what it won't have is any one-to-one relation, any data points of real customers in your synthetic data set. So it will be impossible to reverse engineer the data, and it will be impossible to re-identify your customers once the data set is synthesized. And this helps you to solve this challenge of utility and data utilization versus privacy protection. Because even though synthetic data can't give you 100%, you can get to, let's say, 95%, 99% really good utility while having bulletproof privacy protection. And that's the reason why our customers increasingly start to train and develop all their AI models on synthetic data, because it's nearly as good as real data. It has the same structure, it has the same insights, the same patterns, but it's privacy safe, it's free to use, and they can even easily share it with different subsidiaries across the globe. So quite a few benefits for them. Limitations. What can't you expect synthetic data to deliver? Well, one thing that you need to keep in mind is that it protects privacy, but not proprietary information. So if you have customer data in there that's sensitive, you can be rest assured that once it's synthetic, it's fully anonymous, it's freely shared, it's not in scope of GDPR and other privacy regulations anymore. But even though some organizations openly share the synthetic data, they are aware that synthetic data still might contain some proprietary business information that's sensitive, that they don't want to reveal to their competitors. For example, I don't know how large your most profitable customer segment is, or whom you're targeting, and who, so some details like that, or any more kind of granular information that could be analyzed in the data. So if you want to make sure that this is not something you reveal, if you, for example, want to openly share this data in kind of open data sharing, or if you want to share it with an external party, then you might need to apply additional sampling techniques, because synthetic data itself doesn't take care of these sensitive parts that are not privacy sensitive, but business sensitive proprietary information. Second limitation to consider, as I already mentioned, you can't reverse engineer synthetic data. There's no way that you can ever get back from this data to the individual customers, or even a small group of the original customers. So if you have a use case where you just temporarily want to protect privacy of your customers, but at a later point in time want to get back to the real identity, I don't know, some banks using external service providers to analyze creditworthiness or something like that, then synthetic data is not the tool of your choice. You can definitely use it to develop some credit scoring algorithm, but the inference and using it on real customer data and temporarily synthesizing, let's say, one single subject or something like that, and then wanting to get back to that, that's not something you can do with it. Lastly, it's a big data anonymization technology. So we recommend our customers to use it for data sets up to or starting from 5,000 to 10,000 subjects. If you have, I don't know, medical study of the 50 people who have one of the rarest diseases in the world, synthetic data is not your tool of choice to anonymize that. In fact, it will be super hard to find any tool to anonymize that and protect the privacy because it's just such a small sample. So 5,000, 10,000, this is where you can consider starting. What we see in practice is that our customers most often use this with many hundred thousands or many millions of customers. So definitely a technology that you want to put more in the big data domain. What are the benefits of synthetic data? I hope the first point is already clear by now: eliminating privacy risks, generating data that's fully anonymous and out of scope of privacy regulations. Second benefit is the speed. As I mentioned at the beginning, our customers oftentimes have the issue that they need to wait weeks or months until they get data. Once synthetic data is in place, this is either reduced to a few hours, or they might even have a super innovative organization that provides their data scientists with an internal synthetic data marketplace, where some of the most valuable, some of the most interesting data sets are already proactively synthesized and can be grabbed whenever you need them. Third benefit, I also talked about this, accuracy. If you remember, with legacy anonymization, 2, 3, 4, 5 attributes, and you already run into a significant re-identification risk. So really little information that you can preserve. With synthetic data, you don't get everything, you don't get 100%, but you get super close to the real data. And it's definitely data that's useful to develop AI on. Lastly, the second row, synthetic data helps organizations to collaborate more, both internally as well as externally, with AI vendors, with startups, with fintechs, with researchers, you name it. Because it's useful data, but it's privacy safe data that's out of scope of privacy regulations. This means it can be freely shared, it can be freely uploaded to any online tools like Tableau, cloud services, and so on. Automation, cost saving. More on the organizational side that this is relevant, but oftentimes the costs that involved in legacy anonymization, you wouldn't even want to know how high they are. With automating that, with speeding this up, this can be significantly reduced. And lastly, we will touch about this a little bit today in the bonus section of our training. Synthetic data can also help you to not only create a, let's say, privacy-safe replica of your original, but you can also change and tweak the data. You can make it fairer, you can upsample rare events like fraud cases, and this can help you in certain cases to improve the predictive performance of downstream models that are trained on that data. What does this mean in use cases? For what is synthetic data used? Top use case, I already mentioned it several times, is definitely machine learning and advanced analytics. But we have also organizations who use it for digital product development, because what they see here is that the data is much more granular and allows them to not only understand the average chain and John Does in their data, but also the full spectrum of human diversity. And this then translates also in their ability to develop a bigger variety of services that caters to the needs of the whole customer base. It can be used for software testing, it can be used for external data sharing, it can also be used in responsible AI, AI governance, and AI fairness. It can be used for data retention and many other things. Think of synthetic data as an enabling technology that helps you to unlock your data whenever you want to protect privacy while preserving the utility. So I hope this brought us all on the same page, but I would say now we had enough of the slides and we want to get into the doing and head to our synthetic data platform. So what I want you to do now, I'll stop the screen sharing, and maybe Dilara, you could in the meantime, again, send the link to the AWS bucket or directly to the first data set, the adult census data set that we want to use for our exercise. And then let's get going.
In the Q&A, I think they should be able to reach to the bucket that I shared the link.
I think so, yes. So while Dilara is sharing the link, and I'll quickly take a sip of water, is anybody not on the platform yet? Haven't had time to monitor the chat, so I don't know, but maybe Paul or Dilara. Is there anybody who still has issues, or are we good to go?
So far, nothing in the Q&A session. I'm answering more like people who are curious about synthetic data. So I think we are good.
Are there any general questions? Because then potentially now would a good time to answer them.
There are questions like how they will, for example, one question, how does synthetic data deal with outliers or weird classes in the original data set? I think it will be also
question, but I think this is something that Paul then wants to cover extensively in the section on smart upsampling.
Yeah.
Okay, then I'll proceed with screen sharing. So if you've managed to successfully enter our platform, you should see something like that in front of you, minus all the jobs that you obviously didn't yet have time to do. So what we want to do now is start a very first simple synthetic data job. And for that, what we prepared is actually this file here in our cloud bucket. Some of you might know the publicly available adult census data set. It's data from the US Census. And what we did is we just split it up, this data, in a training sample and a holdout sample, because for the machine learning we're going to do later, you are going to do later with Paul, we want to have a holdout data set. So nothing else was changed, but it was split up into, I think, 80% training sample and 20% holdout sample. So now I wonderfully have the Zoom bar in front of my thing and can't click here, damn it. Sorry for that. So now that we've downloaded our data set, it's really straightforward. We want to launch an ad hoc job. So we're just going to drag and drop our data set there. Okay, that didn't work as nicely. You first have to click and then you have to drop it. Sorry for that. So that's the first step. Once you have done this, you just click on proceed. Now the data set is uploading, and then you can see a few settings, but to be honest, most often you don't even need them. You could, if you want, specify how much synthetic data you want to generate. Remember, I told you earlier, even if your original data set has, I don't know, 1 million samples, you could generate just 100,000 or twice the amount or 10 times the amount, whatever. You could also specify how much of the original data could be utilized. When is or should be utilized for this process. When does this make sense? If you have a data set of 30 million customers, you might want to start with a smaller sample just to see if the quality of the synthetic data is where you want to have it at before you start the full job, which is going to take a little bit longer. Everything else here is not really relevant for us now. You could also specify if you want to have some columns not included and so on. But with this straightforward data set, the only thing you actually have to do is to only click launch job here. So as you can see, not very complicated. If you're curious what happens then, you can look into this view task setting, and there you see a little bit of what happens actually during synthesis. I'm going to open this one as well because it's more informative. I can close the data set here again. So the process in our platform looks like this. First you upload the data, then it's briefly analyzed, it's pre-processed, and then the AI training happens. Plus also several privacy mechanisms that make sure that you learn as much as possible, but not anything that, as I mentioned earlier, gets you into the danger zone of sensitive, privacy-sensitive information. And the last step is actually generating the synthetic data plus creating a quality assurance report. We will get to the quality assurance report once our data set run through, but this is basically your first starting point to get an impression where my privacy checks passed, is the quality where I want it to have. But as mentioned, we will look into that. Since this is now going to take a while, I'm expecting 1 minute, 2 minutes or something like that, we prepared another exercise just to show you that our platform, of course, can deal with more complicated things than just a simple CSV file. So what we also have in the cloud bucket, and if you want, you can do this later, but no need to proceed with it right now, is actually the CD-Now dataset. The CD-Now dataset, in contrast to the adult census dataset, includes behavioral data. And the important thing to know here with behavioral data is that our platform requires you to split these types of data sets up into two pieces. So we have one table here, the customers table, which is our subject table. Every customer is listed in this subject table, one customer per row. First, the purchases, I think here's about CDs, therefore it's called CD now, so it is about CDs. The purchases are listed in a separate table and linked to the different customers, because obviously if I'm a customer of that shop, I would not only purchase potentially a CD once, but I will do this regularly on a weekly basis, or however I have, how frequently I have a need for new CDs or something like that. I actually also prepared a few slides for you, because this is one thing that we want to get clear and want to get, here is, that we want to get across, because you will need this also later for a challenge we prepared for you. So as mentioned, our platform is an anonymization technology. It helps you to fully anonymize data sets while preserving the utility. But what is important is, even though this whole process is as automated as possible, there's a tiny bit that you still need to take care of yourself. And the most important bit of that is actually taking care of your subject. So whenever you use our platform, what I want you to consider is that every subject, being this now a customer, being this an employee, being this a specific contract that belongs to just one person or something like that, like a telecommunication contract, is in one single row, not distributed over multiple rows, because that's the only way that our platform can guarantee privacy. If that's not the case, then our platform would assume that different roles relate to different human beings, and the way the platform would learn the information then could potentially lead to some privacy risks. Therefore, it's super important that each subject is on the one hand a distinct real-world entity, that each row describes only one subject, and that you can treat each row independently. So what does this mean? The content of one row does not affect the content of other rows. To give an illustration, this is a picture-perfect subject table. You have 4 different real-world individuals. I'm sure Max Mustermann exists somewhere. That's the German saying for John Doe, so it's a generic name. But anyways, 4 different subjects, 4 different, or basically their distinct personal information, all in one table. What's not a good example is something like that. So this is a fictitious example of sick leaves, the table where a company registers what type of sickness you had when you couldn't come to the office. And as you can see here, somehow it happens that humans not only get sick once in their lifetime, but apparently several times, like this guy here who was once sick in October and once in November. So as you can see, Martin Schulz is twice in that table, and this violates the rules that I just pointed out earlier. So here you would need to do some pre-processing to make sure that this data fulfills the format. With the 2-table setup, what we want you to do is to split it up in the subject table and the link table. Subject table has all the static information, the time-independent information. Regardless of whether you ask me today or in 1 year time, I will always be Alexandra Ebert. So this is more or less static information. Similarly, my address doesn't change with every purchase and so on. So all these static information should go into the subject table, whereas the behavioral data, the sequential data, the events should go in the linked table. So as you can see here, this is an excerpt of the baseball player data set that we maybe also want to use later. Here you have all the baseball players on the left, their unique ID here, and the linked seasons that they played on the right in the seasons table. One other minor thing that's important here, you can set the IDs, the primary and the foreign key, to link those 2 tables in our platform. But the platform can also automatically detect that if you use this formatting. So what you call the first part before the underscore is up to you. But if you have a column somewhere in the subject table that says ID, and then something in the link table that says underscore ID, it will be automatically detected, and this will mean less work for you. So much about the subject table. We can also provide the slide deck later if you're curious about that. You will find some examples what subject tables are, and that, for example, this needs to be split up, but this is something that will help you later for our challenge. So I'm not going through that in detail now. Going back to our platform, if I manage to get to it, now I revealed Paul's secrets of workflow. So going back to our platform, doing this wonderful drag and drop action again, because Zoom is killing my my top bar. Our job already finished. I promised you to do the to do the two-table setup. So quickly just demonstrating that before we proceed with our adult census data set. In the meantime, I would be curious to know if your job's already finished or if some are still processing. If that's the case, please don't despair. This is our free version and we have currently some capacity limitations. In future tutorials, this will not be the case, but today it could happen that not all of your jobs will finish in 2 minutes like it should normally be the case. So if you want to proceed with your data, if you do the machine learning with Paul later on, you can also grab either the data that's already connected in the notebook, or you can also grab it from the Tiwald bucket if you couldn't get to your own data. If you got to your own data, Paul will explain you how you can use your own synthesized data that you just generated to do the exercises later on. But as mentioned, everything can be found in the cloud bucket. I'm currently in the subfolder, so I'm quickly grabbing the CD Now data set. Sorry for that again, I hope it's not too annoying, but otherwise I can't see where I'm clicking. And if I'm doing a two-table setup now, or basically if I'm doing behavioral data, which means I need to have a two-table setup because our platform also uses different models to deal with different types of data, and it deals with sequential or time series data differently than with static data. So on the one hand, it helps to split this up for privacy reasons, making sure that the data is like that, but even more important, I think, and Paul can correct me on that, is also the data quality. It will be significantly better if you go through this exercise of splitting up the data. So as we did it earlier, as mentioned, you don't have to follow along since the platform, I think, is quite busy, but just that you have seen it once and you can then also do it yourself in the challenge that we will have later on. So my static information are my customers who purchase all the lovely CDs. And then I also have the list of purchases in there. Again, I'm proceeding. As you saw, or as already mentioned, we have the naming conventions here, or we adhere to the naming conventions, so it should be automatically detected what the primary key and the foreign key are to link those two tables together. What is happening now? Why am I not seeing something? It looks like the platform currently has some issues with all the jobs that you're running. As mentioned, sorry for that, some capacity issues and our engineering team being super busy. So it takes a little bit longer than it usually does. In the context of a two-table setup, this will be maybe the first time you're interested in this relationship section here, because what you can see here is the foreign keys that were used. This is the list of tables that you have. So currently we only have 2. If you use a database or more parts of your database, then this list could grow longer and longer. Our customer table doesn't have any reference tables in it. So here's nothing, but if I click on that and scroll down a little, sorry for these delays here. I need a little bit of your patience since the platform is currently so busy doing all of your jobs at the same time. But what you hopefully will be able to see in a few seconds is actually the primary key. There's a field here where it says that's the primary key, and you can then drag and drop. And if you haven't adhered to the naming conventions or want to change something here, you could do so. And due to time, I'm not going to show it now with the link table, but here the same thing. If you click on the arrow, scroll down, you see the foreign key and could also make some changes to that. But enough about the two-table setup now. This is actually just our kind of activity while we waited for the synthesization. But since this is now completed, I want to go back to our job and show you the QA report. I hope it doesn't take too long. It's the first time that we have so many users at the same time on the platform, and we still need to make a little bit of our homework to be better prepared for future tutorials. So bear with us. I hope we are there in a second. If not, I have to use my own workaround that we prepared for all of those of you where we thought it could happen that your jobs don't finish on time. Namely, we already downloaded the QA report to be able to show it to you. So platform, this is your last chance. If you're not loading, then I'm going to do what I just said. Looks like that. So we will come back to that maybe later. But in the meantime, looking back to our cloud bucket, you can see here the training set that we just synthesized. You can see the holdout this wasn't touched at all. This is for later. You can see the synthetic data, which you should be able to upload from download from the platform once it was finished, and also the QA report. If you don't yet have your QA report, if you have, I'm envious because I don't yet have mine. If you don't have it, you can also go here and look into the QA report at the same time as I do, or you can just walk through it with me. So whenever you synthesize data, the two most important questions you and potentially also your business partners have: is this data reliable? Is the quality good? Can you trust it? Is it really privacy safe? And this is what our QA report is for. It helps you to just briefly evaluate, is the accuracy where I want it to be? And did all our automatic mathematical privacy checks pass? So super straightforward. The first thing is the executive summary. And here you can see green check marks. That is what we wanted to see. So all the privacy checks passed. We know this data is fully anonymous. We can use it. We can share it. It's safe. The second thing is the accuracy. I can tell you a little bit later how that's calculated, but it's really a first ballpark estimate how good your synthesization quality is. What does this tell you? Does this tell you that this data is useful for AI? Not directly, therefore we have the evaluation later on, but if this number is high, you can be pretty confident that it will be useful. What you can derive from this number though is that if it's lower than expected, you might have had some encoding issues, did set the data categories not as our platform wants them to do. So side note on that, our platform can automatically detect whether they're numerical, date, time, categorical variables, but if, for example, let's say, I don't know, a zip code, which is a categorical variable, was understood as a numerical variable, this could mess up your accuracy, and then a low value here could be a hint for you to double check if you need to change something in the settings. So executive summary, first impression, everything looks good. What else can we see in the QA report? Well, what we have in there are 4 other things: the univariate distributions, the bivariate distributions, the overall accuracy, and how that is calculated, and the correlation metrics. So I want to find the univariate distributions now. And as you can see here, I hope it's large enough. I'll make it a little bit larger. I'm not sure how big your screens are. I'm currently on my second screen, which is super tiny. So, okay, too large now, I messed it up. Sorry for that. Why are you not reacting?
It looks okay in the screen.
Luca, we have some background noise, I think, with you. Could you maybe mute yourself, or if you wanted to ask a question, ask that question? Thank you. So, okay, I hope it's better now.
It still looks pretty ugly.
Wonderful, thank you. So, univariate distributions. Pretty easy to understand, but basically what you can see here is a visual comparison of the synthetic data versus the original training data. And it's really hard to spot here because the data is so close on, and this is actually also the picture that you want to see. If you go on that, you see that the gray color is for the target data, the real census data set we used, or at least the part that doesn't have the holdout in it, and the synthetic data. And here you can see that the correlations were matched nicely. If this is completely off, again, this could be a hint that, I don't know, zip code was encoded as numerical as opposed to categorical. But that's a first check to see if there are some issues, if your accuracy number is not where you want it to be. More interesting for our purposes when we go in the direction of analytics and AI training are actually the bivariate distributions. Here you compare things like, okay, gender and, I don't know, income or something like that. Is there a correlation between that, or how does the correlation between that look in your original data? How does it look in the synthetic data? The more intense the color, the strongest the correlation. And again, your check here is on a purely visual basis. Does this look similar visually? Do I have the same dark spots in the green as well as in the gray data? Additionally, for some of our customers who aren't that advanced with their data visualization, this can also sometimes be a quite interesting read for them to just scroll through all these correlations and see, okay, there's actually an impact between variable X and, or a correlation between variable X and variable Y or something like that. But we don't want to spend too much time on that because I actually want to preserve enough time for you to work on our models with Paul. So the correlation matrix is also for first glance, do the correlations look good on an overall level? If there are any super strong differences that shouldn't be there, this would be visualized here. But again, here's super weak color. I'm not even sure if you can see the contrast on your screens or not. So everything looks good. Everything looks like we want it to be. And then we have also this, where is it? Okay, I lost it because I'm zoomed in so much. Here, our accuracy metrics, I think it currently is not displayed correctly because it's zoomed in too much, but usually you would see these different values in there. If you have any detailed questions, how exactly this is calculated, you can either check our documentation or ask Paul. I don't know precisely, but it's combining, I think, accuracy calculations from the univariate and bivariate distribution. So much about our QA report. And before I now hand over to Paul, the last two things that I want to show you, or actually just one thing, we decided last minute that Paul will show you the second thing. The last thing I wanted to show you is that, oh, sorry, to make this a little bit more. So does this work now? Okay, no, platform is stuck. Sorry for that. So I promise you, if you come back later when not 100 plus people are working on that at the same time, it will be a matter of seconds until you could go to your jobs. But now use your imagination. If you would click on jobs, you would see that your job is finished. And then there would also be 3 dots where you could click on to either get to your QA report that we just looked at, or and then also once you looked at the QA report, then definitely download your synthetic data, because that's what you want to get from our platform. That is what you want to use and what you can then use to train models on, to share, and so on. Before we do the AI training, Dilara was so kind to also prepare a quick Tableau overview from different plots for us. So basically what we wanted to illustrate here, I'm behind time, so I won't go through it in detail, but as mentioned, synthetic data is completely privacy safe. So if you want to do some visual exploration with it, if you want to use any cloud services and so on, go ahead. You can do it with the data and already get a very good impression, because with synthetic data, you really preserve the granularity of your original data and therefore can dive deeper into the state data. And I don't know, in our US census data set, maybe ask questions like at what age do people work the most, or do the time of work or the time they spend at work actually have something to do with their marital status, and is there a difference between male and female, or is there still a gender pay gap if we only look at different professions and something like that. I think Dilara can also share the link for that, so if you want to dive deeper in that, you can do that later on. But now I actually want to hand over to Paul, because we're a little bit behind schedule and I want to have enough time for machine learning. Before Paul kicks off, and while I'm doing my screen sharing here and getting on Paul's slide, is there actually anything that you want to know or ask now? So one moment. That's the wrong. Okay, sorry, I need to stop that quickly because I closed the PowerPoint in the background. Dilara, did we have any questions when now would be a good time to ask them?
Well, there are many beautiful questions, so I'm trying to answer, but I think more or less in general, like there are one pop-up, which is privacy reports, Q&A related question, which you can find it easily in the links that we will share. And there are some questions like, you know, how we are dealing with the input data that has different type of distribution, so on.
Paul, do you really want to get it right away? I'll currently fix the here.
I mean, the nice part of generative AI is that you don't need to, set kind of any priors. So you don't have to do a parametric model. You don't have to say, oh, this distribution is a Gaussian distribution. This distribution has a fat tail. That also popped up in the questions. You don't need to do that, right? The models, the underlying models, whatever data we are talking now about, is it tabular data, is it image data, is it text data, there is no need to kind of give any priors, and the AI, the models, they detect such things and can model such things very, very efficiently due to the possibility of fitting and detecting and modeling nonlinear effects in there. I know that's a very rough and short answer. Yeah, by the way, I just wanted also to mention that I will actually be in Belgrade from Thursday and Friday. So maybe if you are there too, I'm happy to chat with you and maybe answer one of those questions in more detail. And I do hope that we also solve or answer more questions when we go further in our tutorial. But yeah, I also think there are beautiful questions in there.
I'll also use the time now when you do the machine learning to screen the questions. What we also will share later on, we actually have a Discord community. It's super easy to join. We will give the link to you later on. And this is also a great place to put any questions that will not be answered. I will also copy our questions that we didn't get to answer. Do I need to record some quick videos? So we will write your verbal response. I really recommend you to go in there, because whenever you have any additional questions or use our platform, need some help from Paul and Dilara and our other great colleagues on how to get the best results out of your data, this Discord community can really be of help. Plus, our challenge will also partially require you to go to Discord, because there we can provide and share some additional information that you will need for that. In the meantime, I found my slides again and will share them so that Paul can briefly tell you what's up next.
All right. Yes. Thank you, Alexandra. Now I have to sort my screens a bit. Right. Okay, so Alexandra has given you a very, very brief and fast tour through what synthetic data is, what kind of problems it solves, and she also showed you how our platform works in principle, and how simple our platform is. You just drag and drop things there. The underlying models are, again, not time for details, but there was also a question. The underlying models is essentially a mix of quite common models that are out there. You have GANs, you have potentially transformer, autoregressive stuff. Now diffusion models are coming up, so we have kind of combined all those things to make the platform that produces the highest quality synthetic data that's out there. So that's just again a very short answer to a super interesting question.
Also, as a quick plug for our platform, what our differentiators really compared to open source tools or other vendors is that we have the highest accuracy, particularly for sequential data and behavioral data. So maybe also something to keep in mind, or when you want to play around with synthetic data, looking at behavioral data always gives you the most insights, how sophisticated a platform is, how good a generator really is. Sorry for the interruption, Paul, heading back.
Oh, good. Okay. And yeah, at the end, Alexandra was showing you the QA report, right? The quality assurance report that gives kind of a first hint if everything went all right. So you see correlation patterns that emerge that are the same as in the original data. And that's kind of a very, very good first step. However, now in the tutorial, we want to increase the bar, and we will, look at the data in more detail. And what could be more suitable to check out data and investigate data than to do machine learning on that data? So what we are now planning to do in the remaining 30 minutes is actually, we want to train a machine learning model on the original data, and we want to train a machine learning model on the synthetic data, and then compare the performance of those two models on a holdout of the original data that we took before. Now, where does such a use case appear? We have seen that at several customers that data scientists have either no or very, very limited access to granular level data. And they are then having a hard time to build their models, to dig into the data, to get their hands dirty. And that's where synthetic data can help, right? So they get access to the synthetic data, they test things, they develop models, they try this, they try that. And once they found the best approach, the model that they created is shipped to a high security zone and is kind of scoring the real data. But in order for that use case to work, the performance of the model trained on synthetic data and the model trained on real life data needs really to be on par, and it needs to be comparable. And that's exactly what we are going to test. And the way we are going to test it is shown on this slide. So I've told you before, we have here the training, or our population, our initial population, which is the adult census data. And we split off a holdout of 20% that we do not touch at all and that won't go into our platform. And we have the training data, what we call training data, which is 80% of the data. Here on the left-hand side, you see the standard machine learning workflow. You would send this through a machine learning model of your choice. We will use a random forest and or support vector machines. And then once your model is trained, you would evaluate on the whole lot. Of course, you can do cross-validation and do this and do that, but for the sake of simplicity, that's kind of the basic workflow. Now with synthetic data, we kind of put this section in here. We send the training data, those 80%, through our platform and create a synthetic version of the training data. This training data is then sent through the same machine learning algorithm, train the same algorithm, again, a random forest in our case, and then we evaluate the model trained on synthetic data on the real holdout. So that arrow goes also in here. And then we can compare results. And this is what we are going to do now. And the data set that we are going to use is the adult census data. So this part actually you already covered with Alexandra. You already generated your synthetic data set. The holdout we also provided in the bucket. And yeah, we can start right off. But don't worry if in case your job didn't finish or you didn't manage to download the link or the link didn't work for whatever reason, don't worry. The notebook will provide all the data that's needed to follow along and complete all steps. So we will use the adult census data set, and the task we are going to try to solve is a classification task, because the adult census data set contains one column that is named income. And this column has two categories. One category is income below or equal to $50,000 per year. And the second class is income above $50,000 per year. So that's what we are going to do. And I will share now my screen and show you the notebook in which we do that. So I hope all of you can see my screen right now.
Yeah.
Perfect. So this is the notebook that Dilara has provided the link to. And as a first start, I would highly recommend to click on File and save a copy of this notebook to your drive so that you can, interact with it, that you can work with it, you can change it, you can break it and then fix it again, and so on and so forth. So I copied the notebook to my personal Google Drive, and here we are. All right, as a first step, we will download all the data that we need. So the first part is the training data that you have used for synthesization on the platform. The second file is the holdout, the original holdout, and the third file is synthetic data that we provide. So we did the synthesization run before, and we provided that synthetic data already in order for you to follow along in case anything went wrong during the synthesization. In the meanwhile, let me connect to an instance in Google Colab. And yeah, until this is firing up, I will also talk about the last file that we download, which is the very original data set, which is the adult data set without splitting into training and into holdout set. There are some optional steps in the notebook if you really want to go through all the steps on your own, maybe after the tutorial, right? So you can then go to this specific step where we in the notebook split into holdout and training set. Then you can use the training set to go back to our platform, synthesize. But for simplicity reasons, we provided all those files already. Okay, now I'm connected to my VM. So I first of all load the data. So it downloaded all the files and placed them into some folders. So I placed the files that we need into the data folder and the optional files into the optional data folder. Next step is to import the packages. Also nothing special here. We use scikit-learn, pandas. Then here is the optional step. If you want to do, if you really want to go from scratch, I will not execute that step now, but what it essentially does is it will load the original census file. It will split it into holdout, training set. After that, we have to go back to our platform, synthesize the training data and come back with the synthetic data. I won't execute that. One other thing that I wanted to mention, and it popped up also in the questions, Alexandra mentioned that we have some basic privacy mechanisms in place that kind of actually happen already before we start the training. So I mean, obviously the basic and most powerful privacy mechanism is creating a synthetic model or a generative AI model, but we have basic steps up front. One of them is a rare category protection, and the other one is an outlier protection. Now, the rare category protection kicks in, for example, if there is, let's say, a country which is part of the data set. The native country is a column in the adult census data set. If a native country appears only once, because if we synthesize this naively, this would be a very simple membership of inference attack, right? You could easily say, oh, this record was part of our training data. And in order to avoid this, or in order to be very, very open how we deal with that, we also made it explicit here. So in our platform, those values do not appear in the synthetic data. But that means that when you, for example, train a machine learning model on synthetic data, it could happen that in the original holdout data that you want to score the data afterwards, there is a country or a category that the synthetic model has not seen. And in order to be fully transparent here, we put also this line in here. There is one record that is called, or one native country, which is Holland, that we dropped.
Sorry to interrupt. I
Yes.
also shared the link to the Tableau visualization with you if you want to quickly show that. It's in the chat in Zoom. I'm not sure if the participants can access the chat now or only the FAQ section, but maybe you can just put it on your screen so they can see that actually in the adult census data set, there's only, or Holland actually only appears once as a native country, and therefore that gets eliminated due to our category protection.
Exactly. So what you can see here is kind of the long tail distribution of the native country column of the adult census data set. And you see, okay, there is Hungary, Honduras, Scotland, the same values appear here, or the same categories appear here, however, with a bit different values. So that's the original data, that's the synthetic data. No, the other way, sorry, that's the original data, that's the synthetic data. And you can see that there is one row with a value of Holland, and you can see that this one record is gone in the synthetic data because of our privacy protection. And to be then, again, really fair in the comparison, because when we transform the data with a one-hot encoder, you will get, a different number of inputs for the random forest downstream. And in order to do that and make things easy, we removed that one record from the original data after synthesization. And by doing that, we have the same number of categories in the holdout, in the synthetic data, and in the training data, and make things easy. I know there are smarter ways to do that, but for simplicity and transparency, we wanted to show that here. All right, now we have the data. We have clarified the issue with Holland. Now we load the data and handle the missing values. So you can see here, we read the data that we downloaded before. If you want to, you can replace maybe the synthetic data with the ones that you created. But for the time being, we just run the notebook. And what we also do is we we drop rows that contain missing values. There are a few, not many, but we drop them. And again, to be completely fair, we also equalize the number of records in the training data and in the synthetic data, because it might have changed due to dropping of missing values. And what we end up with is a data set that contains 24,000 rows approximately and 15 columns. The same is true for the synthetic data. Now, before we put that into our models, we transform the columns. Also here, nothing special. We do a one-hot encoding for for categorical features. That's happening here. We kind of transform the numerical features with a scalar, scaling to a value between 0 and 1, and then we transform the training data, and we get the X values, the features for the training, for the synthetic, sorry, for the target, the original data, and the holdout, the test set, and the corresponding targets and labels, the Y values. All right, and with this, we can train a machine learning model. So the first one is a random forest model trained on the original data. Now, this model is pretty simple. Again, we didn't go for complexity due to time reasons and also full transparency. So we train a random forest to predict whether a person is high or low income, and what you get is an accuracy of 84% roughly. When you calculate the area under the curve, that's what you see here. We get an area under the curve of the ROC curve of 0.88. So not a super strong model, but it's doing its job. Now, let's go to the synthetic data and see what happens when we plug synthetic data in. So we train a model on the synthetic data with the same setup, and we do the evaluation. And you see that also for the synthetic data, we get 84% of accuracy. And also when you look at the area under the curve, you get results that are completely on par. And I would briefly like to stop at this point and say that is really, really cool. So we have shown that a model that is trained on synthetic data, but evaluated on the real data, gives really results in terms of accuracy, area under the curve, absolutely comparable, and results that are on par. And this is a really, really strong message. Now, the model that we are using is a random forest, which is obviously not the strongest of models. There are stronger models out there, but I can guarantee you that this also works if you use a support vector machine, as we have also prepared in the notebook, or XGBoost, or you name it, deep learning models applied to the data. This also is true for more powerful models. And you can, if you want to go through the SVM tests, you can also go through that. But for time reasons, I will skip that part right now. And yeah, then I would ask Alexandra to go back to the slides.
I think you need to
stop sharing.
Yeah, once you've stopped, I can do that. We actually, I just had time now to read through the chat, and apparently Dilara can't proactively post to the FAQ section. And so therefore, I'm not sure if everybody already has everything that he or she needs, but in case there's something missing, you need to proactively ask a question so that Dilara can share this link and make it available to you and also everybody else who needs access. Sorry for that. We weren't aware that this is an issue, but I hope this was figured out by you already and everybody is on the call up with Paul. So Paul, handing back to you. Here are the slides.
Yeah. So now kind of we have seen a type of what you put in is what you get out, right? So synthetic data creating, or our platform creating a synthetic copy of the original data with all the same properties. But the beauty of synthetic data is that it can do more. Right? With synthetic data, you can shape, you can bend, you can change the data to your needs. And one of those changes that can be done is what we call smart upsampling. And when you go to the next slide, Alexandra, there you see a bit of kind of a sneak preview of how that will look like in our 3.0 version that will be released beginning of next year. So currently that's not possible in the platform, but it will be made available to you very soon. So what you can do, for example, you go to one of the columns in your data set, which is in this case, I think, countries, and then, no, sorry, the age groups, I'm sorry, it's the age groups. And then you can really type in the percentage of people or of data subjects in every category that you would like to see in your synthetic data. And what you get out then is something like that. So you have the age group distribution here, you have the original data in bluish, and the rebalanced data in greenish. And kind of you could simulate, or a customer of ours could simulate what would happen if my customer base suddenly becomes much younger, because now suddenly there are more people between 25 and 30 than between 30 and 40. And then you can take that data and do an analysis of your, I don't know, revenue, whatever, and you can draw some conclusions from there. And another part or another aspect of this is, imagine you have a data set that is highly imbalanced. Maybe you have a large customer base, but from a certain class, you don't have all the data that you need. You maybe have no labels available. You maybe have some other parts missing that you would need for machine learning. So that's the scenario that we would like to investigate now, where synthetic data can be used to do smart upsampling. And the workflow we show on the next slide. It is.
We actually have our imbalanced data set.
Oh yes. Sorry. In order to simulate such a thing, we artificially imbalanced the adult training data set. So the original adult training data set has a mix of 75% of low income and 25% of high income. And we artificially imbalanced this data set to a distribution of 99% high income and only 1% of low income. And if you plot this in Tableau, that's how the distribution actually looks like. So a really strong imbalance introduced. And what we will do now, that's now shown on the next slide, we will kind of modify slightly the workflow. So we again have our 20% holdout. Now we have the training data, which is however imbalanced. It's imbalanced to 1%, not 0.5. That's a typo here. And then we use this imbalanced data, send it through our platform. And here we can upsample this minority class. And then we send this upsampled data through a machine learning model. And then again, we evaluate it on the holdout, on the original holdout that has the original balance. And we will compare the performance to a model that was trained on the original imbalanced data. All right, and with that, I think I jump back to the Colab.
Yes, I'll quickly stop screen sharing, then you should be able to share yours. You're good to go.
So yes, on the way. Right. So again, we will load some data. Now we use the adult census imbalanced training, and we will load the adult census balanced synthetic data. So again, we did this job for you, the balancing, because in our platform it's currently not possible to do the smart upsampling. Therefore, we provided the data here. There is another optional session here. Here we wanted just to show how we do the imbalancing of the original data set. So again, if you want to repeat everything from scratch, this is the code that you need to do to really kind of create your say your own unbalanced data set. Now here again, we read the data and we pre-process it the same way as we were pre-processing the data before. And what we end up with is a target data set of 14,000 records, 15 columns, and also synthetic data set of 14,000 rows and 15 columns. Now, the way they differ is in the fractions. So if you look at the holdout has, as advertised before, a split of 75 to roughly 25%. The target has this strong imbalance that we talked about before. It's roughly 99% to 1%, and the upsampled synthetic data is modeled such that we almost get a 50-50 split between high income and low income. And that's the data we look into now in detail. So again, we have the shapes here after transformation. So you see that after transforming, we get 103 columns, which means the number of categories is the same, such is the model size, the random forest model. And yeah, now let's see what the random forest does when we throw this data at it. Again, we start with the original data. Just clicking through. We predict and fit. Okay, we get an accuracy of 75%. I guess that's still pretty high because obviously, we have 75% of real data, and I guess the model is mainly predicting zeros. That's at least what's indicated here. And you can also guess that when you plot the area under the curve, you see there is a slight lift below random guessing, but actually it's not really not a really good model in this imbalance case. Now, what happens when you do the when you use the synthetic data, well, again, we train the model on the balanced synthetic data and we evaluate it on the true whole dot. And when you do that, what you get is actually accuracy-wise, it's not much of an increase, but actually the area under the curve really tells you where the benefit lies. And you can see that this model is obviously now much more powerful because it was training on an upsampled data set. And again, here I would like to pause and kind of reflect on what synthetic data or what the AI in our platform was actually capable of doing. So you have a data set with 1%, and we have tested even actually with smaller fractions below 1%, with a tiny signal of this specific minority class. And our system was able to pick up that signal and kind of enhance it, right? It generated new but realistic realizations of people that have a high income that don't exist in practice in our toy model, right? Because we filtered them out, but that give a very realistic estimate of how such people could look like. And this is a very powerful tool. And I need to say, at least for very highly imbalanced data sets, this approach works better than, for example, SMOTE, because SMOTE only does interpolation between existing values. Well, if you only have a few existing values, the interpolation, won't give you a lot. But synthetic data is more creative, is more powerful to create good estimates of people that are part of the minority class. All right, I think that was it for now. We have 5 minutes left. I hand back to Alexandra for that.
So we will come to questions very soon. I mean, Dilara was busy answering all of your questions, but if you have any follow-up questions, then now would also be a good time to ask them. While you do that, I will monitor the chat, so I will be able to see that. Plus, we also wanted to give some information for you. I hope you found this valuable today, how you can continue your synthetic data journey. Oh, and by the way, in regards to valuable, we're really curious to hear your feedback. So even if you don't have a question and could write and type up a little bit of feedback for us, we would really appreciate it because it can help us to improve future tutorials. So any questions and hopefully also some feedback, please type that now in our Q&A section. In the meantime, how to continue your synthetic data journey? Well, we definitely want to invite you to continue using our platform, try it out with different data sets, with your data sets, with publicly available data sets, with any data sets that you can get your hands on and want to synthesize with. Of course, the Colab notebook, I think, also can help with the first evaluation, but really get creative, play around with this data. And immediately also join our Discord community to let us know what you think about the platform, if there are any features that you think would be helpful but that are not in there yet, if you have any questions, you need our support, anything like that, we have our Discord community for. And I just noticed I didn't include the link to join, so maybe Paul, you can briefly go in our Slack channel where Todor copied the link in and made it available, or maybe Lara if you have it on hand. So Discord community, we would highly recommend for you to join. Lastly, or not lastly, but before we come to our big challenge, lastly, what I could recommend is also that you check out some real world synthetic data, because synthetic data is really already now used to do AI training internally on many different data use cases, but it's also technology that both private as well as public sector organizations use to democratize access to data and to share it openly. And one of my favorite examples comes from our customer. Maybe it's one of our favorite examples for that reason. It's Humana, the 4th largest health insurance in the United States. And they, I think December last year, openly published synthetic data from 1.5 million customers. So I think in total you have 10 or 20 or 30 times the amount of customers, but they published a sample of granular insurance data with the healthcare records, which is really something that they did to advance research and to help also startups and smaller businesses and enterprises to access data. If you live in Germany, I'm sorry, this link doesn't work in Germany, but in most other parts of the European Union and the world it does. So if you are in Germany, please make sure that you use a VPN or something like that if you want to access it. And lastly, we also thought of a little challenge for you. So what we want to do with you what we want you to invite to do is join our time series synthetic data challenge. Maybe you can now go ahead and take a little screenshot of that, but we will also provide more detailed information in the Discord community. So this definitely will be then also posted there with some additional information, since we only have 3 minutes left, and I'm not sure if we will be kicked out and you have any additional questions about this challenge. You can also use Discord then to stay in contact with us. But basically what we wanted you to do is to create your first synthetic data job with time series data, where you need to go through this exercise of splitting up the data correctly. So what we will provide to you is the baseball data set. You will get all the links in the Discord community. So I think in the meantime, we were able to share the link to the Discord community with the participants. Paul, Dilara, maybe, or Alex, maybe you can tell me if that's the case. So that
I put it in the chat. I'm not sure if everyone can see it. Otherwise, maybe
if you can't get, I'm not sure if they can access the chat. I think they can maybe anybody ask in the Q&A section about the Discord link, and then I think Paul can reply to that question. Everybody can access it. If you can't take the Discord link away, write me on LinkedIn, do anything to reach out to Mostly AI, the contact form, and you will get it there. So I promise you that if you want to join the challenge, you will get it. Not sure if we can fix this chat and QA's issue. Anyways, goal for you would be to synthesize the very best synthetic data set. So you will get the baseball data set in our challenge folder in the AWS bucket. We will create this in the next 2 hours or something like that. Then you can also check out the more detailed description in the Discord community, more precisely in the online events channel. So give us please 2 hours or something like that, but you will find all the detailed information there. And then you need to correctly split up the table into subject table and link table. We also linked our documentation page. In there, again, you will get all this information in Discord. You can also do some evaluation yourself with building a model to predict actually what we then also want to predict on your synthetic data that you submit, namely the number of games a player will play in the next season. So the target column in the data set is target column G. And we will also provide our RMSE value so that you have something to benchmark yourself on. Then what do you need to submit? Well, actually, your very best synthetic data set to our email address. I know that's fast now, but look out for Discord. Just use this as a subject line, submit it in the next week, and we will announce the winner of this wonderfully beautiful 100-euro Amazon gift card. So I'm not sure if we will be kicked out in any second, but I will look into our QA section now. Paul, can you please reply to this link to the challenge, please, or at least to the Discord community? Dilara is typing.
I did already, so there was already one question regarding
okay.
that.
I'm not sure if participants can still access it. So sorry for that, guys. If there's any issue with that, as mentioned, write me a LinkedIn message or write to hello@mostly.ai to get it, and we will make sure that you can join our Discord community.
No, it should be in the answered section of the chat, of the Q&A session, sorry. And maybe I can answer the last one, the last open question here live. It's about rare category protection, and if that's the only choice we have, like to drop drop values that are so rare. And my answer to that is, well, if privacy is of your concern, you really want to protect the privacy of your data subjects, then yes, there is no way around that. You have to kind of cut off the long tails. But I mean, the long tail, so the number is small. If you have, let's say, around 10 records of a minority class, it's already in there, it will work. But if privacy is not of concern, so it's maybe only machine learning performance or something along those lines, then you will get the option with the 3.0 version. So currently it's not possible, but it will be in the future, to turn off the rare category protection and really to use the full spectrum of data that you have available. That becomes important when you want to do upsampling, when you want to use programmable synthetic data and model the data in a way that suits your use case.
Perfect. Thank you, Paul. So I don't see, oh, there's one other question. Oh, someone doesn't see the answer.
Yeah.
For that, we thought we will have a chat for you where we can post everything in and everybody should be able to access. So a learning for us for next time. if anybody had a question that was not answered, or a follow-up question, or not a sufficient answer to your question, as mentioned, please head over to the Discord community. I'm also pretty confident that this is promoted somewhere on our website, but I must confess I don't know exactly where, so this would be another route to discover it, but I hope we can briefly make this work. Maybe Alex, can you somehow make sure that this link that Paul shared is visible to everybody? I'm not sure what's the best way to operate the system here. Alex, are you with us?
If that's not the case, then maybe I also want to restate that I will be in Belgrade. I will be part actually also of a panel discussion on Thursday. And yeah, if you are there too, and you have some questions, reach out to me and I would be super happy to discuss with you in person.
Excellently. So since we aren't yet kicked out, if you still have a question and want to have it answered live, then now's your chance. Let's see, somebody's typing. Other than that, many, many thanks for being with us today. So it was really cool tutorial, and it was really cool to prepare the tutorial. That's what I wanted to say. I hope it was a cool tutorial for you as well. But from the first feedback I looked over, sounds like you enjoyed it. We definitely want to make this more often in the future. So we would be also super curious to hear from you. What do you want to learn next? Do you want to have a dedicated tutorial on working with behavioral time series data? Do you want to dive deeper into the privacy mechanisms and how to evaluate synthetic data in that realm? What else do you want to learn? Or even if you have any, I don't know, feature ideas or want to learn about new features, then we're also curious to get that feedback. So Discord community is always a good point. If you don't yet have the link and don't want to bother finding it, LinkedIn, reaching out to us directly or just to the contact form is another option. And you can also definitely be curious to check back in the platform at the latest in December this year, because then we will have our major release of 3.0. And next to the cool feature that Paul already introduced in the context of rebalancing, there will be also a few other things in there that will really be helpful for data science and analytics. So be curious about that, and very, very much looking forward to welcoming you back on the platform, hearing your feedback, and also helping us to improve it, to make it most valuable for you, because that's really where we want to get it with that. So from my side, and also from Dilara and Paul, I think thank you for being with us today, and I hope you enjoyed your introduction to privacy preserving machine learning with synthetic data. Many, many thanks.